Problem number 24. Diagram 1 represents the compound AB, which contains two elements A and B. So there's diagram 1. A shown with red spheres, B shown with blue spheres. Label each transformation as a physical change or a chemical reaction. So transformation A is 1 goes to 2. So this turns into that. And then transformation B is 1 goes to 3. So this turns into that. So is transformation A a chemical or physical change? Well, to answer that question, we need to know what chemical and physical changes are. Physical changes occur when a substance is altered without changing its identity, though. Examples of physical changes are melting, freezing, boiling, all the state changes, dissolving even. When you have a physical change, the substance is still the same type of substance, but the particles change their proximity to one another usually. And the particles themselves, though, look the same before and after. Okay, chemical changes, on the other hand, occur when the substances turn into completely different substances, and the particles look very different before and after the change. So thinking about that, looking at the particles might help us. So here in the diagram number 1, the particles are this is a compound AB. The A is the red sphere, B is the blue sphere. So this is a compound of A combined with B. The particles, have both of them combined together. Okay, so transformation A has diagram 1 turning into diagram 2. Okay, now do the particles in diagram 1 look the same as the particles in diagram 2, or do they look different? That would tell us if it's a physical or chemical change. Well, they definitely look different, because in diagram 1, the red ones are connected to the blue ones, but in diagram 2, they're not. The red ones are connected together, and the blue ones are connected together. So this is definitely a chemical change. So I would say in transformation A, this is a chemical change, because, looking at the particles, they look different. Okay, and what about transformation B? Transformation B, this is a physical change, because the particles are still the same type of particles. Okay, you got the red ones connected to the blue ones, and here they look the same. It's just their proximity is changed. They're closer together now versus over here. Now, this is all the question asks for, but I think we can do a little bit more with this. We can identify these elements, I think, in the compounds. The red ones are the oxygens, and the blue ones are the nitrogens. So over here, what we have inside diagram 1 is NO. NO. So I'm going to label this. This is NO. There's one atom of nitrogen connected to one atom of oxygen. And when there's just one, you don't have to write the ones in the chemical formula. And what do we got over here? We have O2 and N2. So we have that one's an O2, and this is an N2. And then again in diagram over, so the blue ones are the N2s, the red ones are the O2s. And then again in diagram number 3, this is NO again. So NO. But look at this situation here. These are close together. I would say this is a liquid or a solid, because the particles are close together. And I would probably classify this as a liquid, because the particles don't look like they're very ordered. They're kind of just you know, randomly close together. They're not all lined up the same way. So I would say this is NO liquid. Over here, they're far apart. I would say this is NO in the gas phase. And then what about here? All of these are far apart, so the oxygens are far apart. I would say that's O2 gas, and this is N2 gas. So with that, we could even provide the chemical equations for transformation A and transformation B. Transformation A, you have 1 going to 2. So what you have is NO gas turns into N2 gas and O2 gas. So that's the chemical equation that describes this chemical change. Okay? Now it's not balanced. I mean, we could balance it, but that's later on in this chapter. Okay, that's how you balance it. And then what about the chemical equation that describes transformation B, that physical change here? So here you had, in transformation B, you had 1 going to 3. NO gas turns to NO liquid. So NO gas turns into NO liquid, and this is already balanced. Physical changes, you know, the chemical equations are always balanced, very easy. So this is the chemical equation that describes this change. It's not a chemical change, so this is actually condensation. You know, gas turns into liquid, it condenses into liquid. So we can say this is condensation of NO. Condensation